Hi TKG Army, very good night to all of you, and today we will start lecture number 3 related to work energy power chapter. So all of you know you already completed two lectures, lecture number 1 and lecture number 2, and in lecture number 1 we completed the details about work, and in lecture number 2 we already completed energy, that is mainly kinetic energy, and the work energy theorem and proof of work energy theorem when a constant and variable force applied on a body. So this is our lecture number 3, and in this lecture, that is today our key point, we will discuss mainly, that is the conservative force and non-conservative force. What is the meaning of conservative force? What is the properties of conservative force? What happens when a conservative force applied on a body? Then we will solve some numericals related to conservative force. Suppose a force F that is equal to xi cap plus yj cap. This value is given. Now you have to say this force is conservative or non-conservative. So this is our today topic. Okay, so first of all you have to know the meaning of, basically to know the actual meaning of potential energy, at first you have to know the meaning of conservative and non-conservative force. So before going to that part, that is the potential energy, at first you see this one, that is the conservative and non-conservative force. So first of all, what is conservative force? In physics, there are mainly two types of force are defined, that is one conservative force and another one that is non-conservative force. So what is conservative force? You see the definition, right? This one, conservative force, that means a force is said to be conservative if the work done by this force when a body displacing from one point to another point doesn't depends upon path. That is, a force is said to be conservative if the work done by this force is path independent, doesn't depends upon path. This is the first point. And second point, you see, it depends only on the ends points, that is, it depends only initial and final position. So write it. So that is the definition of conservative force. So our first point, that is independent, does not depends on path along which the body travels, This is the first point. And second point, that is it depends only on the end points, that is right, depends only on initial and final position, Okay, so a force which is in path independent and it depends only initial and final position is known as conservative force. Now what is the example of conservative force? You see the example, the gravitational force, you see the electrostatic force which is in class 12, okay, and the elastic force of a spring, all are the example of conservative force. So according to conservative force, if I say, you see, suppose this is the initial point and this is the final point. Now suppose a body is moving from initial point A to final point B. What is the path? Suppose the body is going along this path, and I named this path, that is path number 1. Okay, now suppose in another case the body is going from A to B like this path. Suppose I named this path, that is path number 2, and a body is going from A to B like this way. Suppose this is named as path number 3. Now according to our definition, if a force, that is conservative force applied on a body and the body displaced from A to B, then the conservative force says that the work done due to this force along path 1 is exactly equal to work done due to this force along path 2, and it's exactly equal to work done due to this force along path 3. Work done is independent on path. the work done along this path 1 exactly same with the work done along this path, exactly same with the work done along this path, or you can say suppose body is moving like this way, then return back to here, exactly same. That is, it depends on the initial and final position. And you see, for every path here, initial position A and the final position, that is B. So for path 1, you see, for path 1 initial position A and the final position B. For path 2 initial position A and the final position B. For path 3 initial position A and the final position B. So this is the definition. Now you just feel it, why gravitational force is an example of conservative force. Okay, write it. So now write why gravitational force is an example of conservative force. We will prove this one. So for proof this part, suppose you consider a body A. Why gravitational force is conservative. Okay, suppose a body of mass m, this body of mass m rise to the height h, from A to B along vertically upward, rise to the height h. This position is position B. Okay, so this position, that is AB height h. Now question arises, what is the work done for this case? Body is going from A to B vertically upward, that is against gravity. So what is the work done for this case against gravity? Write it. Work done, that is force into displacement. So here work done, okay, you write this value here. Work done against gravity from A to B, that is W equal to force, that is m into g, weight of the body, and displacement, here displacement, that is AB. So this value will be, you see, mg, and the value of AB, that is h. So that is W equal to mgh. Okay, so this is the first case. Now if I say the body is moving, rise to the height h, but the path not same, the path is like this one, you see. So here second case, body, same body, mass m, going from A to B, this is the position A to B, but the path is not like that, the path is like this one, A to C, now you see C to D, now D to E, and then E to B. So in second condition, if I say the body is going from A to B, rise to the height h, but the path is like along A, C, D, E, B. Now what is the work done in second condition? You find it. So for finding work done, you write this one. For second case, work done for figure 2, suppose this is our figure 2, that is W equal to work done, at first you find work done along A to C, that is WAC, plus then you find work done along C to D, that is WCD, then you find work done along D to E, that is WDE, then work done from E to B. Now you see, from C to D and E to B, you see the gravity, direction of the gravity downward, and the displacement of the body that like this way, direction of the gravity downward and the displacement this way. So this angle is 90, and you know the meaning of work done, W equal to F dot S, that is F is cos theta. So when theta is equal to 90 degree, this work done result will be 0. You see here from C to D, the direction of force and the direction of displacement 90. In same way, from E to B, the force directed downward and the direction of body, that is E to B, force directed downward, the direction of body E to B, so angle is 90. So work done for C to D, this work done is 0. Work done for D to E, this work done is 0. Now what is work done for A to C? Formula, that is force mg, and the height here, height, that means A to C, that is AC, plus what is about WDE formula, that is force mg, and the height for DE, this one is the height, D to E, that is DE. Now take a common, mg common, so this is AC plus DE. Now what about AC plus DE? This one AC and this value is DE, this one is DE, that is AC plus DE, that means total height, that is AB. So you write that is mg into AB, and you know AB height, that is h. So this value is mgh. Now you see, in first, according to figure 1, we find work done, and the result of work done, you see this one, that is mgh, when the body is moving from A to B like vertically upward. This is the path number 1. Again from figure 2, we change the path and the body is going from A to B. That is the body is raised height h, but here work done, that is also is equal to mgh. Path change but work done equal. So what you can say? You can say that the work done is path independent, and a force which is path independent is known as conservative force. So here you see the gravitational force is an example of conservative force, because gravitational force is path independent. Okay. Now we'll prove another theory, right? We'll prove when a force applied and the body goes around a circular trip, around a round trip, then the total work done, that is equal to 0. We'll prove this part when a conservative force applied on a body. Okay. So for this case, so at first you have to draw the diagram. Okay. Suppose the body is moving from A to B along path 1, and this is along path 2. Okay. This is along path 2. The body is going from initial point A to the final point B, either along path 1 or along path 2. Now if I say, if a conservative force applied on a body, if applied on a body and the body going from A to B, either path 1 or path 2, what we can write? Conservative, that is path independent, that means we can write the work done along path 1 is exactly equal to the work done along path 2. So write it. At first you write the statement, right? Suppose a conservative force if applied on a body and then the body goes from point, that is the initial point A, to the final point that is B. So mathematically you can write mathematically you can write work done WAV either path 1, that is exactly equal to work done along work done AB either path 2. Why? Because a conservative force applied here, and conservative force is path independent. Okay. Now another case, if I say the body is going from A to B, but the body is going A to B like path 1 and return back from B to C return back from B to C like path 2. The body is going from A to B along path 1 and return back B to A, return at the same position but along path 2. So you can write it. Okay, you write, but if the body is going A to B along path 1 and return back B to A along path 2, then we write work done on the particle along path 2 from A to B is exactly equal to minus of work done on the particle along path 2 from B to A. You see, work done on the particle along path 2 from A to B. This is the case. A to B along path 2 exactly equal to work done on the particle along path 2 from B to A. Here initial and final position change. Here when the body is going from A to B along path 2, this is the initial position, and when the body is returned back along path 2, this is the initial position. Okay, that's why the negative. Now you see, you can write here, that is work done WAB along path 2 is equal to minus of WBA, that is also along path 2. Suppose this is our equation 1 and this is our this is equation 2 and this is our equation 1. Now you see, if I compare equation 1 and equation 2, equation 1, WAB either along path 1, either path 1 is equal to WAB either path 2, and here WAB along path 2 is equal to minus of WBA along path 2. So you write, by comparing equation 1 and 2, we can write this one, WAB along path 2, that means WAB along path 1, so WAB along path 1 is equal to here minus of WBA, and this one is along path 2, Now if I write here WAB along path 1 plus of WBA along path 2, that is equal to 0. You take this one that side, so this one will be positive. So this one you can write W for closed path, answer is 0. This is the statement. The statement is, if a conservative force acts on a body and the body displaces, the body goes around a round trip in a circular path, body goes around a round trip, that is A to B and return back from B to A, then the work done for this closed path is result 0. Okay, this is an important theorem. This is an important properties also. So what is the properties of conservative force? First property is conservative force is independent upon path. Second property is conservative force is depends only the initial and final position of the body. Third property is, when a conservative force applied on a body and the body displaces around a round trip, then the work done for this closed path, that is equal to 0. Okay. Now there are another force which is named as non-conservative force, exactly opposite to the conservative force. Conservative force path independent, but the non-conservative force is path dependent. You see the definition, write it. If the amount of work done in moving an object against a force from one point to another point, it depends on the path along which the body moves, such a force is known as non-conservative force. And what is the example of non-conservative force? You think it? Force of friction. Force of friction is depends upon path, the state of the path, the state of the nature of the surface of the path. Viscosity, which we will discuss later. There is another chapter which is separate chapter named as viscosity, and viscous force is also an example of non-conservative force, because these types of forces are depends upon the path along which the body moves. So there are two forces, conservative and non-conservative force. Now question arises, what is the difference between conservative and non-conservative forces? You write it, the difference between conservative and non-conservative force. First difference. So what is the difference between conservative and non-conservative force? So conservative force and their non-conservative force. Non-conservative force. Okay, now write. In case of conservative force, work done along path 1 is exactly equal to work done along path 2. If I consider two paths, and suppose body is going from A to B, this is path 1 and this is path 2, path 1 and path 2. So work done along path 1 exactly equal to work done along path 2, and here this is path dependent. So work done along path 1 is doesn't equal to work done along path 2. Now second one, it depends upon path, right? Depends upon path, not depends, it doesn't depends upon, does not depends upon path along which the body moves, along which the body moves, and here it depends upon path along which the body moves. And third point, for a round trip, work done for a closed path, if a conservative force applied, that is 0, and here if a non-conservative force applied, work done for a closed path, if a non-conservative force applied, is not equal to 0. Okay, so this is all about theoretical part. Now is important numericals. Force value given and you have to say this force is conservative or non-conservative. How? So we will solve these types of numericals. Okay, see problem number 1. In problem number 1, f vector, that is x I cap plus y j cap, given, and you have to say this force is conservative, non-conservative, depends only x and depends upon x and y. So what is the method? Right, suppose if f vector is equal to fx I cap plus fy j cap plus fz k cap, and if this force is conservative, this force must satisfy the given three condition. What is the condition? Condition number 1, del fx by del y is equal to del fy by del x. Condition number 2, del fz by del x is equal to del fz by del fx by del z. And condition number 3, that is del fy by del z is equal to del fz by del y. If a force is satisfy these three conditions, then you must say the force is conservative. Not only single condition, all three conditions must have to satisfy. And why I say this one is del? Del, that means the partial differentiation. You have to differentiate fx, that is the x component of force, fx with respect to y, then the reverse one. You have to differentiate fy with respect to x. And in same way, you see, if z, you have to differentiate if z, that is the z component of x, with respect to x, then the reverse one. If x, you have to differentiate x with respect to z. At first here with respect to x, fz, and here with respect to z, fx. And the last one, that is you have to differentiate fy with respect to z, then fz with respect to y. Okay, now solve it. You see problem 1. So according to problem 1, what is fx? F vector, that is x I cap plus y j cap, and k cap is not given. Okay, that is 0. So here fx, that means x, and fy, that means y, and fz value is not given, 0 k cap. So fz value is 0. Now you check first one, del fx by del y, right? Del fx by del y, that is equal to del fy by del x. Now you check del y in the place of fx, here fx, that is x, that is equal to del x fy, the value of fy, that is y. So you have to differentiate x with respect to y. So this answer will be 0. If differentiation del y of y, the answer will be 1. But here this value is x, and you are differentiating with respect to y. So this x is constant. So constant differentiation 0. Again here you see, differentiating with respect to x, but here the value is y. Y is constant, it's not variable. So this value is 0. So our first condition satisfy. Now you check second condition, right? Del fz by del x is equal to del fx by del z. Now see, del x of what is fz here? You see fz not here, k cap is not given, so fz value is 0. So del x of 0, that is equal to del z of fx, and fx, that value is x. So del x of 0, answer is 0, and del z of x, x is constant because you are differentiating with respect to z, so this value is 0. So second condition is satisfied. Now check third condition, and the third condition, del fy by del z is equal to del fz by del y. So del z of what is fy, that is y, that is equal to del y of what is fz, that is 0. So del z of y constant, so this differentiation 0, and del y of 0, answer is 0. So here all three conditions are satisfied. So what is the answer? Answer is this force is conservative. Okay, so method is you check these three conditions. Okay, now second one, this is a homework, you solve it. If that is 2y I cap plus 2x j cap given, and the answer conservative, non-conservative, depends on only x or depends upon x and y. This is the question. Now you solve. You at first check condition 1, condition 2 and condition 3. If all three conditions are satisfied, then you say conservative. If anyone is not satisfied, so first condition is not satisfied, so don't check second and third one. First one is not satisfied, so you can easily say that is the non-conservative force. Okay, now this is your homework. Now I will solve this one, problem number 3. Okay, check it. So in problem 3, which value is given? F vector given. F vector, that is equal to 3y square I cap plus 4x square j cap. And same thing, you have to say this force is conservative, non-conservative, depends only x and depends upon x and y. So you check first condition, del fx by del y, that is equal to del fy by del x. Now see, del y of what is fx here? First one 3y square, So write 3y square, that is equal to del x of, you check, okay, you write this one is left hand side, you check separately here. What is the answer? What will be the answer? You see, del y of 3y square, here 3 constant outside, del y of y square, so this one will be 2 into y, that is 6y, and right hand side this value is given del fy by del x, that is del x of, in the place of fy you have to write, what is fy? You see 4x square, and fz value is here also 0, there is no k cap, so fy, that is 4x square. Now you see del x of 4x square, so 4 constant outside, del x of x square, so this one will be 2x, that is 8x. Now you just check del x of del y, that is 6y, and del fy by del x, that is 8x. So you can easily write this is not equal to. If this one is equal to, you can check another one through 2 and 3, but here first one is not satisfied, so you can easily say this is non-conservative. So third question answer is, this one is non-conservative force. Okay, now see problem 4. Read it, write down the numericals. So in problem 4, a force, the value given, acts on a body and it is taken from A to B. This one is point A, this one is point B, along 2 paths. This one is path number 1, the state, and this one is path number 2. Now you have to say which one is correct. W1 is equal to W2. W1 is equal to W2, that means the force is conservative, path independent. W1 not equal to W2, that is the force is non-conservative. And third one, W1 greater than W2, and the reverse one, W2 is greater than W1. Okay, so solve it. Same thing, you have to check these 3 conditions. Here f vector, that is x square I cap plus y j cap. Now you check first one, left hand side, you check del fx by del y, that is del y of, what is fx here? Fx, that is first one, x square, so this answer is 0 because you are differentiating with respect to y, here x square, so this value is constant. Now you check this one, del fy by del x, del fy by del x, this is the right hand side, that is del x of, what is the value of fy? This one, y, so this answer is also 0. So first equation is satisfied. Now check second equation. Second equation, del fz by del x, that is del x of, what is fz? Here not k cap given, so this is 0 k cap, so fz value is 0, so this differentiation will be 0. And del fx by del z, del fx by del z, that is del z of fx, that is x square. So same thing, differentiating with respect to z, so x square constant, so this answer is 0. So our second equation is also satisfied. Now check third equation, check it, del fy by del z, that is del z of fy value, that is y, so this answer is 0. And del fz by del y, that is del y of fz, that is 0, so this answer is 0. So our all 3 conditions are satisfied. So if this 3 condition is satisfied, so which one is the correct answer? You write this one in the comment box. Okay, so students, this is all about conservative and non-conservative force. So I think this part is clear to all of you. You solve second one and tell me the answer in the comment box. Now you say which one will be the correct answer, because this problem is solved all 3 sections. So today I am ending here. Meet you soon next class. Till then, tada.